Kellen, would you read the directions for the first problem, please?
A number line can represent positions that are north and south of the truck stop on a highway. Decide whether you want positive positions to be north or south of the truck stop. Then plot the following positions. A, truck stop, B, north, the truck stop, C, 3.5 north stop.
Okay, so number line. So you have to decide which way you want north to be. Left or right? Right? So you want north over here. That would obviously be south and negative over here then. All right, truck stop. Where do you think the truck stop should be represented? Right here. 5 miles north, so that would have to be this way. 3.5, so not quite as far from the truck stop. The opposite direction. So those would be the points you needed to label. Probably could go A, B, C to label those three. Question 2. Josh, what do you got?
Negative and positive for east and west.
Negative and positive, certainly. Just like we talked about yesterday. Hopefully you followed the same diagram that they did. West being positive, east being negative. Or sorry, they did west negative, east positive. Doesn't matter, but we're going to use that to answer the next question with the people that are cycling. So since they did west that way and east this way, I am going to do the same. 0 represents their starting point. Where is Lynn at? 5 meters per second. And it says they go for 5 seconds, it says in the problem. Brooklyn. 25. Diego. Evan. -4 meters per second for 5 seconds. -20, so a little closer. Again, that doesn't mean he's going backwards. That just refers to direction. Elena. Brooks.
15 meters per second.
15. Just about wrote your name down there, Brooks. Elena. And remember, Noah's on the next page. Chesney. -30. So those should be the points we should have labeled there. Find the value of each expression, question 3. Again, working on positive and negatives. The first one should be review from the first 5 lessons or so that we talked about. You got one of each. What's the rule when you got one of each, Colin? You subtract it. So what's 16.2 minus 8.4? And then you take the sign of the bigger number. What's bigger, 16 or 8? So my answer's got to be positive. Just go to the one underneath it. Now I got 2 negatives, Corbin. What do I need to do when I got 2 negatives? Remember our rule? What's that? It does not make it positive. That's multiplying. We haven't gotten to that. We'll actually talk about that today. Yeah, you add them together. Just like if it's 2 positives, you just add them together and you take the sign. So 7.2 plus 7, or 9.2 plus 7.
16.
And now I take the sign. Negative. Next one, 2/5 minus 3/5. Remember, if you prefer the adding rules, you always put a little plus sign right in between the number and the negative sign. So if you prefer those rules, it'd be the same as 2/5 plus a -3/5. Jonas. You have one more 1/5 that is negative. Again, one of each here, adding rules, I'd subtract, take the sign of the bigger number. Last one here, remember, 2 negatives in a row. Kinley, 2 negatives in a row, what happens? Makes those 2 things both positive. Does not affect the front one. So now I have one of each. Kellen,
The answer or what I should do?
what should you do?
Subtract.
You should subtract. All right, so 4 3/8 minus 1 1/4. Need a common denominator? 2/8. What do you get? Negative
That's the same problem.
3.
Yeah, I just looked back at the problem.
Yeah.
Yes, it was the exact same as this one.
Yeah, that's
Yeah,
what
I just looked for the answer.
This one was the same deal as well. Those two just repeated.
Yeah.
All right, so question number 4. We got started on that one yesterday before you left. We needed to figure out how much I spent on the paper products of napkins and paper plates, because that's what I got taxed on. So 5 into 19, move my decimal 2 spots. 5 into 19, 3. 5 into 40. That should be it. So that means I spent $3.80 on my paper products. It wants to know how much I spent on the watermelon. Well, my total bill is $8.25. I spent $3.80 on paper products. That should tell me whatever's left is my watermelon cost. Georgia? I agree with that. $4.45. Question 5, next page. For each equation, write 2 or more equations using the same numbers that express the relationships in a different way. So I'm only using 3, 2, and 5 here. Brody. Got one? Sure.
2 plus 3 equals 5.
Got one more?
5 minus 3 equals 2.
Perfect. And there's obviously another one, but it only asks you for 2. There's 4 in every fact family. Next one. Miss Nielsen, you got it?
3.4 plus 7.9 equals 10 to 5.
Got another one? Perfect. Jonas.
15 minus 7 equals 8, and 7 plus 8 equals 15.
Good. Evan.
9 over 5 plus 3 over 2 equals 33 over 10. 33 over 10 minus 3 over 2 equals 9.
Good. Now, you didn't have to have those exact 2. Remember, there's 3. But you did have to show 2. Question D. Which graphs cannot represent a proportional relationship? Review from Unit 1. Who hasn't answered yet? Sophia, have you answered one yet? Okay, why B?
Because it's not
It is what? Not what?
linear.
Very good. Has to be linear. And you got another one? Why? Doesn't go through origin. Okay, it has to be linear and it has to go through the origin to be a proportional relationship on a graph.